Hello all, this is Raju Pujala. In this video, let's take a look at how to develop our machine learning model. And this is our first ML model in this playlist. I hope you are excited, and I will try to explain this in very simple steps. Okay, let's quickly jump into our Colab notebook here. So if in case if you have not watched my previous videos, I suggest you to watch all the previous videos. So this is a continuation to the previous video. So in the previous video, we split the data and we have data. So let's do our first model, develop machine learning model. Okay, cool. So what I'm going to do, so if we look at this map, so this is like a universe. This is like a go-to-go map for every machine learning developer or a data scientist. So you have to start go. I mean, you have to follow from the start. And if your data set has more than 50 samples, then if you're predicting a category like zeros, ones, and all, and then you have a label data. Yes, we have a label data, and it is supervised learning, and then we have to follow all this tree map and all. So we will definitely go through all of this one, but right now I'm going to pick one of the easiest, simple, and the best ML models for you, and we are going with ensemble classifiers. So let's pick the model. And how do we get to know like which model we have to take? So this tree, I mean this flow that you have to follow, one. And second thing is that it's all about like trial and error. You take bunch of models and then you try, you run, and then you see like which is like perfectly fitting for you. And then now let's go back to here. So we have our x-train data, right? And we have our y-train data. We are going to use this data to develop our model. Okay, for that I'm going to use from sklearn.ensemble import random forest classifier. So this is the model. So this one I'm going to call as rf is equal to random forest classifier. So this is a n estimators is equal to 100. Whether you give this one or you don't give this one, it doesn't matter. So but I'm by default n estimator is equal to 100. Okay, if you print rf, so we have successfully imported this library, and this is the model. Now we have our model, but we have not passed the data yet. So I'm going to pass this x-train data and y-train data over here. So rf dot, let's train the model by using the keyword code fit x-train y-train. So basically we are giving all the inputs and their actual values as well. So now let's run this one. Okay. So now our model is trained. That's it. See, it is just with few simple steps. Actually, you can train your model. So if you would like to see how much time it took for you, so you can use the magic operators, percentile time. So basically, this gives how much time it takes. So right now, it took only like 293 milliseconds for the CPU time, and the overall wall time is 307 milliseconds. Okay, which is not even a second. So this is like really, it happened really quick. It's because we have less data, right? Now this is how we train the model quickly by using the data. And now what we have to do, so let's see whether how this model performs on the test data. So if you remember this one, we have training data and test data. So this is the test data, and this is the test values. So now what I'm going to do, we are going to predict the values using this data, and we will compare against this data. So for example, let's see predictions. Okay. um, so it's very easy. So our model name is rf here. So rf dot predict, I would like to predict, and I would like to pass the data x test. For example, let's say only pass x test 1. Okay, x test is x test, I'm passing only one data. So let's predict this one. So it has predicted the value as 0, right? And now let's see what is the actual y test values. So y test of 1, so this is 0. So our model, it has predicted the value as 0, and the actual value is also 0, right? So which means that our model is predicting fine. So let's predict for like all the values. Predict x test. Okay, this is all the values that it has predicted for x test. And remember, this is our x test data. This is our X test. So this one, so the age is 64 and all. For this one, it has predicted this one 0, and the original values for this one are this one. So if you would like to have this in the same format as this one, you can use np.array. Okay, and you can see the values. Now let's compare how well it is matching. So I'm going to have this as y preds. So y preds is equal y predictions is equal to rf dot fit x test. Okay, so this is the y preds value, and we have sorry, predict. Now let's do this one, mp dot mean y preds is equal to y test. So I'm checking whether these values are matching or not. So it is telling that all the values which are predicted versus the actual values, it is matching. And how else? What else? How else we can find this one? This is one of the ways. The other one is that by using the accuracy score model from sklearn learn that metrics import accuracy score. So why we are doing this one? The same one over here, we will find the accuracy by using the libraries. So print f accuracy score, accuracy score of y test. These are the actual values, and the predicted values y preds. And then let's run this one. So the accuracy score is 100%, which means that our model is predicting everything accurately and is giving 100% of accuracy. So this is how you can train your models, and you can find the accuracy score. I hope this is clear. So what we have done over here, so earlier we have a data set, right? And what we did, we split the data set into x and y, and then again we split x and y into x train, y train. Okay, let's say the data set has 1000 rows. Okay, we split the columns by using 1000, and extend train we gave like 800, and x test, y test we gave as 200, and train model on x train and y train. Okay, and then predict values, I mean, for the on the unseen x test. Okay, and then compare the predicted values with y test, because for this x test, these are the actual values is in the y test. So whatever the predicted here, it will compare with the virtual values. If both are matching, then it is perfect, it is predicting accurately. So this is how we develop the models. Thank you for watching this video. I hope you are liking this content. Please do watch rest of the videos as well. I wish you all the best.